Welcome to this video. We will be using the text blob package in order to create summaries for large text. This exercise uses the earning call dataset. This dataset, as you remember, contains the full text of company's earning calls as well as some metadata such as the date, the company name, and the sector. Indeed, if you take a look at the text of one of these earning calls, for instance, let's take a look at the first one. So I'm going just to take a look at the first earning call, and text is the second column, 1. You can see that it's such a huge amount of text. The earning calls are presentations of companies to the media and shareholders, and those presentations are recorded and transcribed verbatim, and they also include some question-answer sessions at the end. This amount of information contains very useful data for analytics and can reflect on the sentiment of the company executives as well as the strategic plan of the company. Nonetheless, this is such a big amount of text to be read, especially if we have multiple of these calls. Our goal here is to summarize these earning calls, and we're going to use two strategies. One strategy is to select noun phrases, because noun phrases many often contains the kind of most meaning of the text, as well as using part-of-speech tagging to look at nouns. Again, very often verbs are mined for actions, and nouns somehow are mined in order to create summary of the things or concepts in the text. For each one of them, we want to focus on the most frequent occurrences of these noun phrases and also words, noun words. We have a bunch of these companies here. So what we're going to do, we're going just to look at one of these companies, and then we're going to isolate the process in a function that we can apply on the remaining of the companies. What I'm going to do now, I'm going to assign that piece of text to a variable called text. My next step is to create a blob object by wrapping text to the constructor of the text blob. Now I am interested in noun phrases, so I can call noun phrases from the blob object, and this will basically return a list of these noun phrases. You can see some of the noun phrases convey some meaning, so you can look at genuine southern hospitality, unique differentiators, goodness, celebration, nominate colleagues, some of them are proper nouns, so on and so forth. But there are many of them, and we want to create a summary. So the next step is to basically count the most frequent ones. What I'm going to do, I'm going to create a series from these noun phrases. And the reason I'm going to create a series is that I want to use a function that pandas series provide called value counts, which will basically count the values in the series and return another series in which the values are the index and the counts are the values. So we can see here that, and they're actually sorted by default. We can enforce the sort another, to be sure, but they're sorted. And you can see here that some of the common noun phrases are Kevin Miles. Presumably this person plays a role in the company. Executive officer, probably Kevin Miles is the executive officer. Some meaningless words repeated because this is a transcript, such as yeah and thanks. But we want to pick a couple of them. So what I'm going to do, I'm going to pick maybe 10 or 15 of these. And that should give us something about the summary of the call. So you can see that they're talking about restaurant sales. A couple of other nouns here. Maybe we can go to 25 to see more, what's going on in this earning call. So obviously this is not a perfect list, and we may want to filter this. So we can involve some ad hoc filtering. Maybe we don't want to look at words that contain sentences that contain one word. Maybe you want to have 2 or more words to convey some meaning. Things like thanks, Zoe, Kevin, Stifle, Jason, they're not very important, right? So we can involve some ad hoc filtering of this data. So what I'm going to do here, I'm going to assign this to series, a series S, and I am going to I'm going to isolate this in a function. Let's call this one summary, sum1. Here, I'm going to return S. So now this function can operate on any piece of text, including the first earning call, including the second earning call, including all of the earning calls. So that's the second earning call, for instance. Oops, it's not 1, it's 1, 1. That's the second earning call. Okay, now again, as I said, we can involve some ad hoc filtering if we wish. So I can look at noun phrases that have a couple of more than one noun. So here, for instance, I can say, okay, just give me S here, right? That will give me a series. And let's focus on noun of the series that, entries of the series that contain more than one word. An easy way to look at this is to split, for instance, and count. So for instance, let's assign this to S2. I'm going to do S2.str.split.str.len. That basically give me the number of words in each one of these noun sentences. And then I can create a mask. Let's say I'm interested in more than one word here. That's my mask, and then I can mask my series here. So that basically gives me noun phrases more than one word. So this is interesting because you can see that a lot of the junk has been taken care of. Again, there is no science behind this. There is a process of trial and error and figuring out what we want to do. And obviously the question here is a bit open-ended. So let's do this here. I'm going to well, this is S actually, so this is S here, and then what I'm going to do, I'm going to return S2 dot value counts, and I'm going to return the first 15 entry. So when I do the summary now, I get a more condensed summary because I'm kind of taking out the junk words. Okay. So that's the second company here, and the second company is Autodesk, and you obviously see a lot of people's name, but they're talking about some business model transition and new models. So there is something going on about change in that earning call, because these things were so frequent in the text. Next, we want to apply this function to all of these earning calls. So what we can do, we can take our text series from the data frame. Okay, and then we are going to apply the function that we wrote called sum1. And that basically will create a summary for each one of the earning calls. Now, they won't show up nicely in the notebook. I think the best way to look at them is to save them as another file, exporting them. So that's something one can take care of afterwards. Indeed, it's actually created a data frame, and that's probably not what I want, because these words are not common across all of the earning calls. So what I'm going to do here, I'm going to change this to a dictionary. Okay, so if I apply sum1 now, I'm going to get for each one of the earning calls a dictionary mapping the noun phrases to their frequencies. I'm going to save this one in the data frame. Once again, I think the best way to look at these is to save them as a text file or a CSV file, because they don't show up very nicely in the notebook. Next, we are going to try another way to summarize these, and we are going to look at nouns in the text. And we're going to use part-of-speech tagging, so we will look at nouns, proper nouns, plural proper nouns, and plural nouns. So NN, NNP, and NPS, and NNS. I'm going to employ the same strategy. I'm going to take just one of these earning call and figure out how I get to the part-of-speech tags, and then I'm going to isolate the steps in a function that I call apply on all of the earning calls in the data frame. So the very first step is to create the text blob object in text, from text. Next, we can call the part-of-speech tags attributes here, which will basically invoke the part-of-speech tagging algorithm and give me this as a list of tuples. So now I know that each one of these words is and a part-of-speech tag associated with it. Now the next step is to filter these words. And here I have two options. I can either create a data frame out of this list of tuples, or I can use just Python to do it. Since this is a list, I'm going to use a list comprehension. Now, notice that each element in this list is a tuple. So if I do T for T in blob.pois tags, that will basically give me the same list. Now, because each one of these is tuple, I can access T0, which will give me back the word, and T1, which will give me the tag, right? Now, I need to zero here because I am going to look at, I'm interested in the words, but I want to make sure that my T1 is one of these part-of-speech tags that I'm interested in, which are NN, NNP, NNPS, and NNS. That will basically only give me nouns here. Another way to do it is to basically unpack the tuple in the iteration here. So I'm going just to keep this one here for reference. What I'm going to do, I'm going to, instead of reading a tuple, I'm going to unpack it to word and tag, and I'm going to focus at word here and invoke tag there. That's essentially the same, it's slightly more readable. For word tag in blob, part-of-speech tags, that will unpack each tuple to two variables. And I want the word, but I want to make sure the tag is one of these tags. Let's call these, that's exactly the same thing. I'm going to call this one nouns. Next, I'm going to count the frequent nouns. So I'm going to invoke the same strategy. I'm going to create a pandas series from nouns. And I'm going to call value counts. That will basically count these nouns. And again, I'm going to create, to pull maybe the top 15, 25 common nouns in common values, common nouns in the series. And I can make it a dictionary just like what I did above here. Okay, so now I know how to do it with one of these text. I'm going to isolate it in a function. So same technique, I'm going to create a function, I'm going to call it sum2. It's going to take text as a parameter, and I'm going to just include all of these steps. And make sure I don't have a copy-paste mistake. The key important link is here, linking the parameter to the variable here. And I'm going to return series here to dict. Now I'm going to make my functions a bit more useful. Instead of hard coding 15 here, let's include a variable called top n, and I'm going to make it 15 as default. So it's a default parameter, but I think that's make it much more useful, so the user can use these functions to extract more than 15 frequent noun phrases or 15 frequent nouns from the earning calls. Similar to what I've done here, I'm going to do sum2, apply sum2, and that will basically invoke the function sum2 in each one of these earning calls, and I'm going to get the most frequent nouns in each. If we take a look at our data frame here, again, it doesn't show up nicely here, but you can see the idea here. You can see the most common noun phrases and the most common nouns in each one of these earning calls.